This area here, this is the feed hopper, the first process step in this mill for the Lucky Strike mill. We're dumping an ore bucket into the hopper. It goes on a variable speed feeder, feeds a trio impact crusher that puts ore into our fine ore bin in the plant. So this is the very first step of our process. Comes from the hopper outside, goes on a screen. Fine material goes up to the mill bin. Ore size goes back to the crusher. Let's head up into the ball mill. All the crushed ore reports to this. It's coming out on this feeder. You can see the kind of crush we're getting. It's really good. This is what's feeding the mill. Some improvements that have been made in this area is we added a VFD. That's a variable speed controller. What it does is it controls the tonnage going into the mill. Before we had this, there wasn't a way to control tonnage. This is our new belt scale. That's the tons per hour that's currently being operated. The two work together to control the tonnage into the ball mill. The slurry from the ball mill comes from this tank. What this tank does is we add reagents and chemicals to the slurry that helps the flotation process work. Come on up and have a look. So all that slurry from the ball mill is coming here. It's agitated. We add a collector and a frother to this slurry for the next step for flotation. Over here, these are the chemicals. This is the reagent rendition area. We put all new pipes, new hoses in this whole system. It's pumping out of here, it's mixed, and we control the flow rate of the chemicals into the plant right here. So from the conditioning tank, all that slurry flows by gravity into the flotation row. These first three cells here, they are the roughers, meaning they make a rough concentrate. This right here is the froth. You can see the mineralization on it. It's pulling over. The concentrate from these three cells go to the cleaners. The tailing tailings from these 3 cells go to the rougher scavengers. Their purpose is to scavenge any of the concentrate, valuable minerals that are left from the roughers, that what they did not get. Sending it down. These are the final cleaner cells. What floats off of these cells is final product. From here it goes to a filter press system. We press it out, get the water out of it, make a filter cake, which we'll show you later on in the video. This is final concentrate. This flotation row that you see right here, it's currently out of service. However, it is wired up, it's available for service. And its purpose, it'll take feed out of that same conditioning tank. You only need to run this if you start running higher throughput and higher tonnages. So as tonnage goes up in the plant, we have future plans to put these in service. And you'll have 2 rougher flotation rows at that time. Concentrate for the flotation rows is going to report here. This is a drum vacuum filter. It takes the concentrate, comes as a slurry here. This drum is submerged in the slurry. As it goes around, it sucks the concentrate to it, and then it peels it off like you're seeing right here. It dumps it down a chute, and it goes into our concentrate bag, and it's ready for final shipping at that point. This is final concentrate. It's a cake. You can see the mineralization in it. This is what it's supposed to look like. Okay, this is a Falcon concentrator. It's basically a mechanical gold pan. Right now it's not being operated, but it's available to operate. It really depends on the kind of ore that we're receiving on whether we run this unit or not. So if we get coarse gold in our ore, this system will have to run. And the way it runs is 1/3 of the feed will come to this, the rest will still go to flotation, and then it cycles back around. Very valuable machine, nice to have on site. Gives us an option for various types of gold coming through our plant. This is our tailings thickener. All the slurry that comes through the plant after we've extracted all the valuable minerals out of it, the tailings reports here. And what this thickener does is all the solids settle out the bottom, clear overflow water comes across the top, and that water is recycled and used again in the plant. Currently, this is being operated properly. We don't have to use hardly any makeup water. We recycle a good 80–85% of our water from this thickener right here. The way it works is we add a flocculant, we add a polymer chemical to the tailings slurry. It makes all the solids in the tailings coagulate together and settle out. When they settle out to the bottom of this tank, there's rakes that are spinning around the tank. Rakes all the heavy solids to a pump, which is right there. And that pump pumps the heavy solids to our tailings impoundment. We recover the water. Okay, these are concentrate thickeners. We have auctions for these thickeners here to receive feed from the flotation row. They operate real similar to a tailings thickener. The purpose is to thicken up the concentrate before it goes to the drum press. Today, with the low-grade commissioning ore we're operating, we don't really need to operate these. When we get into the higher-grade ores, these will become a critical part of the operation. We have 2 of them, one primary and one is standby. As we mentioned earlier in the drum press, all the concentrate from the drum press falls down this chute and it goes in that super sack. And that super sack is what we ship our concentrate in. That's final product. Currently, we're just topping off a bag today. That bag will be complete today, and depending on the assay results, it may be a sellable product right now, even with the low-grade concentrate. Okay, this here is the gold room. In the ball mill, there's a jig that's built into the system. If we have nuggety type ore coming through, meaning we got gold nuggets in the ore, you're not going to be able to float it, and it won't work well in the Falcon concentrator either. However, the jig will recover those nuggets. You take those nuggets that you recover, it'll make a concentrate, you bring it into here, and this is the gold room where we can separate the gold from the jig con right here. Currently it's not operating because we don't have that type of gold in our ore today. However, it's another good option for this plant. This plant is set up to recover gravity separation on gold, flotation gold, or nuggety type gold. So we're set up to collect whatever various type of ore types we have coming in. Over here, this plant did not have a system for potable water. We didn't have restrooms or anything. So the team put a potable water system in. Let's go have a look. I'll show you what it looks like. So this is our potable water system. It goes through a chlorination and a filter system before it becomes potable water. It's a high pressure system that pumps potable water to emergency showers in the plant, eye wash stations, and also the restroom facilities. Suitable for potable use. Works flawlessly. Really good system. Guys did a good job. They had to build this room around it and everything. Let's go over here and look in the lab. See if they're prepped. Okay, over here, this is our prep lab. In this room here, we have the ability to crush samples, prep them, separate them, dry them, and weigh them. Currently, we have an operator that's prepping a concentrate sample. Why don't you explain what you're doing, Evan?
Right now, I'm pouring the concentrate from flotation cleaners into here to suck out as much moisture as I can. After that, I go to the hot plate, take out the rest of the moisture, make it dry.
So you got a sample here that's dried and ready to shoot. So that's a sample that he prepped earlier. He's dried it, got the moisture out of it, dried it. It's a sample of concentrate. And you shoot it with the XRF gun, it'll give us an indication of what we have collected for valuable minerals. Does it come up?
Yeah.
All right, let's see what it says. What do we got?
Silver's at 763. We got gold at 436. Our iron, 97%.
Okay, so even on the low-grade ore, we're collecting gold, we're collecting some silver, fair amount of iron in the con. That's something the metallurgical testing is going to determine on, do we need to collect that iron? If we don't, we'll have the ability to sink it in flotation. So he records all the lab data right there, and it actually goes on part of our KPIs, which we'll show you our KPI board here in just a second. Here's the remainder of the lab. In the past, it had the ability to do fire assay, and it still will in the future. Once we get going, we have the ability to do all assays right here. This is just a general repair bay. We can pull a loader or equipment in here, fix our stuff right in, we've got workbenches, tools, that's everything we need to maintain the plant. supervisor's office. They have their daily line outs, toolbox meetings in here. They've also established KPIs, key performance indicators. So these are the targets, these are the actuals. So ball meal density, that's one of the things we have to control to get good flotation. Percent passing, that's how well we grind. You can see we're doing fairly well. Classifier density of 25, that's what's going to flotation. Vector underflow, everything's here. These are our targets, these are our actuals. So yesterday they made 273 pounds of con, but we had an issue with the crusher and we only crushed, we only ran 3 hours. So we didn't crush very much. However, it's a good measurement tool for the crew. Sets targets and goals. These targets are always ramping up as we commission. All right, up here is just a side overview of the site. This building here to the far right, that is our diesel storage tank. It holds 10,000 gallons, and it is recessed in the ground in a concrete bunker. So it is environmental compliant for spill containment. The next building over here to the left, that's the main office building and showers and change room building. And over here to the far left, that is the plant. That is the mill and the operating plant. The vacant area where the loader is, that is our ore storage. All trucks come in and dump right there, and we feed the plant that way. The old head frame that you see, that is from the Lucky Strike mine, which is right below us.